Hello and welcome to Haltech Elite Part 4. I know it's been 3.5 years since I started this series. I kind of started it as a Christmas project during the holidays one time and kind of ran out of time to finish it once the holidays finished, but I noticed since we did a few videos over the last few months, we did the Astra Turbo and some of the Link ECU stuff, that the Haltech videos actually got quite a lot of views. There's been some requests to carry them on, and yeah, we'll try and get that done, seeing as this channel's getting some decent amount of views and subscribers coming now. So the next part we're going to look at was the ignition setup. So I've got a R34 GTR base map we did for another customer. It's not the same file we worked on before, but it's very similar. The only thing to state about this car is that it was running a single throttle body rather than the GTR's normal individual throttle bodies. But for what we need to do, it's good enough. So let's look at the setup and main setup of the ignition system. So we've got the ignition tab here. So the first thing to look at is the ignition angle load source. So this is where you're going to determine what you use to input into your ignition map table here. You can either run it on a map sensor, you can run it on air mass per cylinder, but that requires your fuel mapping to be accurate. You can do it on throttle position, and you can do an engine pressure ratio. Kind of similar to what you can do on the fuel map. So the next thing to look at is the ignition system mode. So you've got direct fire, wasted spark, distributor, twin distributor, and single wire CDI. I've only ever really used the top three here. So direct fire means you allocate a output wire to each cylinder from the Haltech. So in an Elite 2500, for example, you can have up to 8 coils. You basically wire each individual coil on its own, and you have them fitted to each spark plug, and they can be fired one at a time per cylinder as that cylinder is on its firing stroke. So some coils will have built igniters. The Haltech Elite itself doesn't have a strong enough igniter, so we found a while back we had some Fiat T-Jet coils, and the Haltech could just about make a spark when the spark plug was outside the cylinder, but you put it in the cylinder under compression, didn't have the energy to fire the spark plug. So that one actually would needed a igniter module between the Haltech and the coil. If you've got something like a VW coil or an R8 coil, for example, then they can fire directly. So you can literally wire the Haltech straight to those coil packs and they will fire, no problem. Next option you've got is weighted spark, and this is where you pair two cylinders up on the same coil pack. Example of that would be the R53 Supercharged Cooper S Mini. They run a coil pack on top of the engine. It's got 2 coils in it, and each of those 2 coils has 2 lead outputs. So one coil drives cylinder 1 and 4, and one coil drives cylinders 2 and 3. So you pair the cylinders that are at the top and the bottom together, and you fire them both on their fire stroke and also their exhaust stroke. So one of the things you should probably do is not plug your coil packs into your ECU until you've got these settings right, because if these are wrong, you can actually burn your coil packs out just by having the key on. So the trigger edge of the coil can either be falling or rising edge, and this means that the voltage on the wire to the coil is either held at 0 volts or 12 volts. So on a falling edge coil, for example, it will be held at 12 volts constantly, and for the dwell charge time it will drop for whatever milliseconds the dwell is to 0 volts and rise back up. The rising edge means it sits down at 0 volts, the coil will rise up to 12 volts briefly to charge the coil and then drop back down to 0 volts to cause the fire. If you have this backwards, effectively your wire could be sitting there for several seconds at a time trying to charge a coil and just burn a coil out. So you make sure you've got this setting right before you plug your coils in. So there's another type of dwell mode here. I've only ever come across constant charge coils, but there obviously are other options like constant duty. Just make sure all these settings here are correct before you head on and actually plug your coils in or start cranking your engine. So the next thing on here we've also got is the lock mode. Now we looked at this in the trigger setup, where you would set it to always on, which basically locks your ignition timing to one fixed timing, which is good for using your timing light to verify that your engine is timed up correctly on your triggers. You can completely disable this, or you can actually put it on during flood clear, which means if you're full throttle during cranking, the engine will lock the timing to help clear the engine if it's flooded. Alright, so we've got another bunch of tables here we can enable or disable to correct our ignition angle. These will appear on the side here. and you can turn on the ones or turn off the ones you do or do not need. So we've got the overall ignition correction, which means you've got a fixed value to add or remove from any ignition output. Attack and decay corrections are allowing to smoothing the transition from a high ignition angle to a low ignition angle, so you can't suddenly jump from -20 to +30 degrees. There'll be a delay time. Cranking ignition angles used for when the key's being used to turn the engine over, but the engine hasn't fired yet, so you might want to lock your ignition time into a specific angle for doing cranking. You might stick it to like 2 degrees, something while you're cranking, regardless of what's going on with the throttle input. Zero demand can be useful on some engines to help the idle. So what you can do is set up a table here which comes on when the throttle position is 0, and based on engine speed, so if you've got a target idle of say 1000 RPM, anything below that you might put a high ignition value, 20-25 degrees in, and you might say, well, if you get to 1100 degrees, put it to -10, and this can be used as a crude sort of idle control. You could also use it so when you lift off, you go into decel and have a high RPMs have a certain retard or something to use during decel. Coolant temp and air temp corrections, again, just based on those temperature sensors, you can add or remove timing. You might say when the engine's cold, add a bit of timing. You might say when you've got high air temperatures, you might retard the timing a couple of degrees just to help, prevent knock. Post-start correction is used, so for the first sort of 60 seconds after the engine start, depending on temperature of the coolant, you can add a bit of timing to help hold the revs up or help the engine warm up, or retard the timing for catalyst warming or something, whatever you want to do. Individual cylinder corrections mean that, say you've got a specific cylinder that's always going to knock, you might preemptively always pull 1 degree off that cylinder, because the knock control in Haltech, when it picks up knock on any cylinder, it will retard all cylinders in that bank. So you might find that you end up retarding 2 degrees out of one cylinder and then losing 2 degrees out of the other 5 cylinders for no reason, because they're not knocking, you're losing power. Where you could put one cylinder specifically to have less timing in it, so it never knocks, never triggers the knock sensor, and the other cylinders can then run more advanced. Gear correction you might want to use, so let's say you've got a certain amount of boost pressure in first and second, but you can't go below that, you're still getting traction issues, you can actually retard the timing to manage the torque. You've got a bunch of generic correction options here that you can use, so you could put any sensor inputs that you like, or some sort of switch or something to change the ignition. However you want to set these up, you can set up all sorts of things. It's just depends how creative you want to be. And then finally, there's a fuel composition correction table here which you can use, which is like for a flex fuel sensor thing. I probably wouldn't use this. I'd probably set up a 4D map instead. I can show you how to do that now. So this is a 3D map, so you've got input 1, input 2, and then the third dimension is the output. Well, if you go up to your table setup, you can actually enable fuel composition here, and you might say 0% alcohol, 20, 40, 60, 80, and then what you'll get is an extra input here. You can have several copies of the map based on different alcohol contents, so you might want to look at doing that instead. Other tables that we've just seen in the main setup then appear down here, so as you can see, you've got your cranking angle, your zero demand you might want to use for idle, so you can see here, around the idle area. This is quite a high idling engine because it had 290 degree cams or something. You might want to set 10 degrees here to hold the idle, but if the revs drop, you bring some timing in to increase the engine torque output and bring the revs back up, and as it starts to go above your target, it'll bring the revs down again. Then you've got your individual cylinder trims as well. The only final thing to be aware of is down here under ignition system, you've got dwell time. Now this is the charge time of the coil pack. You will need to find out what the exact values for your coil pack should be, because different coil packs require vastly different dwell times. If your dwell time is too weak, then you won't get a good spark, or it will just get a misfire. If your dwell time is too high though, you can actually burn your coil out in literally minutes or hours of usage, and then you start getting misfires several hours down the line because your coil pack's died because you've been burning it out using the wrong dwell time. So consult your specifications of your coil pack for the voltages and different RPMs and what dwell times you should use, and that's all you should need to do to get your ignition system up and running. Alright, thanks for watching.